Assistant Professor, Department of Computer Applications, Dr. N.G.P. Arts and Science College. In this video, we are going to see Introduction to Pandas data structures, declaring series, selecting the internal elements, assigning values to the elements, defining series from NumPy arrays and other series, filtering values, operations and mathematical functions, evaluating values, not a number values, series as dictionaries, operations between series. Introduction to Pandas data structures. Normally, Pandas supports two different type of data structure. One is series and another one is data frame. Series is a sequence of one-dimensional data. It is like a one-dimensional array. Data frame is a complex data structures with several dimensions. It is like a multi-dimensional array. Series is an object of Pandas library. It consists of two one-dimensional array. One set of dimension we have index, another set of dimension we have values. Normally index value will be of integer data type and starts with 0. In this example, we have four set of values. First value will be stored in 0 and second value will be first position and so on. How to declare a series? So this is a syntax to declare a series. PD dot series, within a bracket we have to mention what are all the values we want to create as a series. Before that we have to import the Pandas library. So PD is alias name for Pandas, series is a function. So after executing this, the series will be stored in S. When we want to display the contents of series, it's enough to mention the series name alone. Otherwise, we may give print S also. So when we are giving S, it will print the values along with the index value. It is always preferable to create a series using meaningful indexes. We may have our own values or we want to have our own values instead of 0, 1, 2, 3 for index value. This is an example for creating our own index values. PD dot series, within a bracket the values and the index. In this example, I want to have A, B, C, D alphabets instead of 0, 1, 2, 3. When I printing the values of series, it will print the value along with the index values as A, B, C, D. How to retrieve the elements or how to select the elements? Normally, the series will print two different arrays. One array, it will print the values and another array, it will print the index. So for that, we have to give S dot values. It will print the elements which is stored in the series. S dot index will print the index values. How to select the internal elements? When I want to select a particular element in a series, I have to mention the index value. Here S of 2 will give the value which is stored in the second index. Likewise, S of B will be display the value which is stored in the B index. When I want to print or I want to display multiple values means this is also possible. Here I have used the slicing operation 0:2. It will select the multiple values. For the slicing operation, we have to mention the minimum and the maximum range. That is 0 to the maximum range and the maximum value will be excluded. That is, it will take only 0 and 1 index values. Another way to select the multiple values are S of B, C, likewise. Okay. In this example, it will select the values which is stored in the B index as well C index. This is another way to select multiple values. How to assign a values to elements? When I want to assign a new value instead of existing value, it is also possible. Here I have used S of 1 is equal to 0. So new value is 0. That value will be assigned in the first index value. Likewise, S of B is equal to 1. The new value 1 will be assigned in the B index. So when we print the series after assigning, it will display the new contents or new elements. How to define a series from NumPy arrays? It is possible to create series from an existing array or an existing dictionaries or series. The values contained in the NumPy arrays or the original series are not copied, but they are passed by references. If I want to create or if I want to convert the array as a series, we should not copy the content and paste to the series. It is not possible. Instead of that, we have to pass the values by reference. So changes in the argument NumPy or series will also be reflected in the newly created series object. Here I have created an array using NumPy. NP is alias name for NumPy dot array. Within a bracket I have to mention what are the elements I want to have in the array. The next step will be I am passing this array to the series 1 to convert that array as a series. So S3 is a series which contains the array values which was already created. When I want to print the series, it will print the values which is stored in the arrays. S4 is equal to pd dot series of S. This is an example to convert the existing series to series. So S is already created series. Now I want to create it as another series. When I am printing S4, it will print the contents. Operations and mathematical functions performed in series. Like NumPy arrays, the operators, all the arithmetic operations will be used in series also, and the mathematical functions also are applicable to object series. So when I am using the division operator in the series S divided by 2, all the internal elements in the series will be divided by 2. The first value, if I have as 12, it is divided by 2 and it will be assigned as 6. And the second value, if I have minus 4, it will be divided by 2 and it will be assigned as minus 2, like that. Using mathematical functions, we have plenty of mathematical functions in series. Here I have used np dot log of S. np is alias name for pandas. Log of S, log is a mathematical functions. For that I have to pass the series. Here after executing this, all the elements will be computed its logarithmic values. Here in the output series, not a number will be displayed because we are not normally computing the logarithmic values for negative numbers. So, but in the series I have a negative value in the first position. So it will not compute. Instead of printing the output, it will give not a number value. There are unique functions in pandas series. The first one will be unique. A series may contain the duplicate values. Duplicate values means the same function will be presenting in various positions. So this is an example for having duplicate values. In the 0th index I have 1, as well in the 3rd position also I have 1. So this series will contain duplicate values. Likewise, index values also may have duplicates 1. Okay. When I want to print the values excluding duplicates, I want to have only the distinct values, means I have to use a unique function. The return value of this function will be an array containing the duplicate, so containing the unique values of the series excluding the duplicate values. For that I have used SERD. SERD is my series name dot unique within open bracket and close bracket, because this is a function. It will print the values excluding the duplicate one. Value counts function, it returns unique values but calculates their occurrences within the series and prints them. How many times the value will be repeated, that will be returned as a output. Third, SERD, it is my series name dot value of counts. It will print how many times the duplicate values will be present in the series. Isn't, it is a membership evaluating function. It returns whether some values are present in the series or not. If the values are present in the series, it will give the true, otherwise it will give false. So SERD, it is my series name. I want to know whether the 0 or 3 values are present in the series or not. This in 0, 3. So 0, in 0th position, whether I have some value, it will give true. Otherwise, it will give false. NaN, not a number. Pandas supports not a number values for sometimes we want to have missing values, or when we don't want to create, or when we don't want to define any values in some positions. We want to leave that position. So for that we have to mention there as a not a number. Sometimes calculations of logarithmic for negative values also result in not a number values. These NaN values are a problem during data analysis because for a negative values, the logarithmic values will not be computed. For missing values, we can use np.nan. So here I have given a example pd.series within a bracket 5 minus 3 np is a pandas alias name .nan. So in the second position, I want to leave a number. Functions is null and not null function are used to identify the indexes without a value. I want to check whether any values are missing in the index position, like that. So is null, it checks whether any value is missing in a position. If any value is not present in a particular index, it will go true, otherwise it is false. Likewise, it is a not null. It is opposite to is null. We can create a series from an existing dictionaries. Like we have created a series from existing array. No? Likewise, we can create a series from the dictionaries. So before that, I have to create a dictionary with some labels. Red label consists of 2000, blue label consists of 1000, yellow label consists of 500, and orange 1000. So this is the syntax to create my dictionary as a series. pd.series, my dictionary name should be passed as an argument. It will print the values. Operations between series. Series align data address differently between them by identifying their corresponding label. So this is an dictionary. I have created a series by passing the dictionary. So my series 2 will be my series. Already I have some content in the my series. When I want to add these two series, it will check the label values. If both the values are same in both series, it will add the values. Otherwise, it will give not a number. Through this video, we learned the data structures in Pandas, how the series data structures will be implemented in Python, and the operations performed on series, and how to create a series from other data structures like arrays and dictionaries. Thank you for watching this video.